Alright, so you've got a scene in Unreal, you switch to Path Tracer, hit render, and boom, Grain City. In this scene, I will show you how I set up a path tracing in Unreal Engine 5 and clean up that noisy mess in DaVinci Resolve. Super simple, super clean, let's roll. Before we jump in, if you're into this scene, I've dropped the link in the description. It's really awesome pack and totally worth it checking out. Alright, first thing, we're gonna switch our viewport from lit, lumen to path tracing. That's gonna give us physically accurate lighting and shadows, perfect for high-end renders. Now, I'm inside my sequencer with a simple camera setup, just a slow reveal to show off the details in this compass model. Next, I will head over to the post-process volume and scroll down to the path tracing section. The first setting here is max bounces. It's set to 32 by default, but I'm gonna knock it down to something like 8. Why? Because 32 bounces can be a bit overkill for most scenes. It increases render time a lot, and most of the extra light bounces won't even be visible. Reducing it to 8 still gives you great indirect lighting, while keeping render times more manageable. Next up, we've got the samples per pixel parameter. This one controls how many light samples are taken for each pixel in your render. The higher this number, the cleaner and less noisy your final image will be. But keep in mind, it also increases render time per frame. You can actually see this in action with the progress bar at the bottom of the viewport while rendering. Each pass adds more detail and reduces the noise gradually. And if you're wondering how to toggle that progress display bar, here is a quick tip. You can use the console command r.pathtracing.progressDisplay and 1 to turn it on, or set it to 0 to turn it off. I'm going to set this value to 500. It's a solid balance between quality and speed, especially for this scene. Right under that, we've got max path intensity. This basically a clamp that prevents super bright light paths from blowing out your image. It's set to 24 by default, and for most situations, including this one, that's totally fine, so I'll leave it as it is. Next, we've got the emissive materials checkbox, and this one is checked by default. What it does is allow emissive surfaces in your scene like glowing lights or neon signs to actually emit light in path tracing. So if you've got materials that are meant to glow and cast light, this needs to stay on. Moving on, there's the reference depth of field option. I'm also keeping this one off because my scene doesn't rely on atmosphere or fog volumes being referenced directly from a camera. If your scene uses complex atmospheric effects tied to a specific camera, that's when you would check it. And finally, we've got the denoiser. Now, I'm unchecking this because I will be doing my denoising later in DaVinci Resolve, where I have more flexibility and control. Unreal's built-in denoiser is decent, but if you're planning to polish your shots in post, it's better to work with raw data and denoise externally. Alright, next I'm gonna expand the lighting components section, and yeah, we've got a bunch of checkboxes here. Let's break them down real quick. First up, we've got emissive. This lets emissive materials contribute to the lighting in the scene, like glowing glass or neon lights. It's super cool, but in this shot, I don't need it affecting the lighting, so I'm keeping it unchecked. You can see here how it would look if enabled. Then we've got the essentials, diffuse and indirect diffuse. These control how direct and bounced light interact with your surfaces. Definitely keeping these on. Next is specular and indirect specular. These handle reflections and highlights, both direct and from bounced light. Gotta have these checked too. And finally, we have volume and indirect volume, which are all about volumetric effects, like fog or atmospheric scattering. Even if you don't have heavy fog in your scene, it's a good idea to keep them enabled just in case. Alright, let's see how we can render this out. I'm gonna bring up the movie render queue, and first thing first, I will delete the JPEG format and deferred rendering because we're rendering this with the path tracer and we want everything set up for that. Now, let's start by adding anti-aliasing. I'm setting both spatial and temporal sample counts to 16. That means for every frame, Unreal is going to take 60 spatial samples per pixel and 16 temporal samples to reduce noise and smooth out motion. Super useful when working with path tracing, where noise is a big deal. Also, I will set override anti-aliasing to none, since Path Tracer handles its own anti-aliasing separately, and we don't want conflicting settings. Next, I want my render in EXR format. This gives me high dynamic range and preserves all the fine color and lighting detail for compositing later. Now, I will add the Path Tracer option to tell Unreal to use it for rendering. And then I will add the color output settings. Inside that, I will make sure to disable the tone mapping curve. This keeps the render linear and avoids baked in contrast or color shifts, which is perfect if you plan to color grade or composite in post. Finally, I will set the resolution to 4K and we're ready to render this shot. Alright, now I'm in DaVinci Resolve. Since we've checked the disable tone curve back in Unreal, when we rendered, we are working with a linear color space, which means the image might look a little bit different out at first. To get the most accurate and natural looking result, we need to convert that linear data into something our screens understand. So let's head to the color tab and I will drop in a color space transform node. Inside the settings, I'm gonna set the input gamma to linear because that's what Unreal gave us. Then I will set the output gamma to sRGB since that's the standard color space for most monitors and web delivery, but you can use Rec 709 too. Now, this simple adjustment brings our image into right range, and now the render looks way more natural. I will definitely create a full tutorial on color spaces and rendering workflows soon, but for now, this quick fix will do the job. Alright, the last thing I'm gonna do here is drop in a noise reduction node to clean up the render. Since we didn't use Unreal's built-in denoiser, we've got some raw noise to deal with, especially in the darker areas and soft shadows. So I will go into the settings and carefully increase the luma and chroma thresholds in both the temporal and spatial sections. The key here is to reduce the noise without softening or losing too much detail. So always find that sweet spot. And with that done, we're ready to jump into color grading and post-processing. And that's it for this one, folks. I hope this gave you a clear look at rendering with path tracing in UE5 and denoising in Resolve. If you found it helpful, drop a like and don't forget to subscribe for more Unreal Engine content. Catch you in the next one.